Page 5 now. The instructions say simplify and then combine if possible. Right now, this is a pair of unlike radicals. The radicand is different, even though they're both square roots. But if we simplify them, sometimes we get some like radicals. This changes to, if you divide by 2, you get 25, perfect square. Very nice. And then plus, what happens here? Divide that by 2, you get 16, another perfect square. And then these are going to change to 5 square root of 2 plus 4 square root of 2. Now after the simplifying, the 5 and the 4 are coefficients. They're both square roots. The radicand is the same in both, 2. So 5 root 2's added to 4 root 2's gives us this answer, 9 root 2's, or 9 times the square root 2. And if you want to check this, if you pop all this in the calculator, square root 50 added to square root 32, you should get the same exact decimal as if you do 9 times the square root of 2. Slide over here. This is simplified as much as it possibly can be already. Now we saw square root of 8 a little while ago. Maybe you remember. That changes to root 4 root 2. I'm just going to copy this like a good teacher. And this becomes 5 times 2 times root 2, which in turn becomes 10 square root 2. At this point we have the like radicals, root 2's, square root 2's, 3 of them plus 10 of them. Final answer, 13 square root 2. Like I said about the previous example, get a calculator decimal answer for that and compare it to that. They should be exactly the same. 13 times square root 2 should be the same as if you do all this mishmash back here. Getting ever so slightly larger numbers. Well, 18, we've seen that already on this document. This is 9 times 2. And I think we saw 98 earlier also. That's 49 times 2. So this simplifies into 6 times 3 times square root 2. This changes to 5 times 7 times square root 2. And if we multiply these out, that's 18 square root 2 plus 35 square root 2. It's just like 18x plus 35x. We add the coefficients and we get 53 square root 2's, or 53 times the square root of 2 is the same exact value as what we began with. Okay, this is our final answer. Slide over here. Cube roots. Oh, just take it slow. And remember, 16 is not a perfect cube, but if we divide it by 2, we get an 8. 8 is a perfect cube. I'm going to factor the cube root of 16, like so. 54, remember that 5 minus 5, that's just a coefficient. 54 is not a perfect cube, but if we divide that by 2, you get 27. 27 is a perfect cube. 27 is 3 to the 3rd power. So there's 16 broken down, and there's 54 broken down. Now if we change these to their other value, this becomes 6 times 2 times cube root of 2. Subtract 5 times 3 times cube root 2. So that's 12. 12 cube root 2's, take away 15 cube root 2's. We do have like radicals, both cube root, both radicand 2. So 15 of them take away, 12 of them take away 15 of them. That's going to be minus 3, or negative 3 cube root of 2 for our final answer. Okay. And moving down the paper, here's some variables thrown in. They're both square roots, so I'm back to looking for perfect squares. And with the exponent, of course, I'm looking for exponents divisible by 2. So the x to the third power, I'm going to factor that like so. And just keep the y squared as it is for the moment. Minus 2y, and do likewise with that x to the third power. Stop for a second, make sure I didn't make any mistakes. There's the x to the third, y squared, and there's the x to the third. Okay, so where is the radical sign going to disappear? Here, and also here. So this becomes 5xy, 5xy, square root x. That's the only thing still left under the radical. And minus 2y times, that becomes x, square root x. So we have 5xy root x minus 2yx root x. Of course, this is xy versus yx. They're really the same. Since it's multiplication, the order does not matter. If it's bothering anyone, let me just be very explicit here. I can rewrite this 2xy root x. So now you see we do have like terms, which include a like radical, xy root x. 5 of these, take away 2 of these, makes the final answer 3xy root x. Okay. Moving over to the right. Try to simplify this. Again, it's square roots. So 18 breaks down into 9 times 2. 9 is a perfect square. P to the fourth, that is already divisible by 2, so I'm not going to factor it. This doesn't change at all. That's as simple as that gets. So what happens here? We get 5 times 3 times p squared, and square root 2 remains. Just copying that part. And then this is 15 p squared, square root 2, plus 11 square root 2. Now, even though we have the like radicals of square root 2, we've got 15 p squared in front of that one, and just a plain old 11 in front of that one. So this is a different term than this. We don't have like terms, meaning we're done. Got to know when to stop. Stop right there. That is our final answer for that question. And now to the bottom row. Oh boy, 3 terms. This is nothing new. That's 9 times 2. And that's 9 times 3. And finally, that's 25 times 2. And this changes to a 3. 11 times 3 times square root of 2 plus 3 square root of 3 minus 10 times 5 times square root 2. And if I do these little multiplication steps, I got 33 root 2 plus 3 root 3 minus 50 root 2. Now, looking at the results at this point, those match. Those are like radicals. This one's different, so that one is not going to get joined with anything else, but we can combine these like radicals. 33 root 2s minus 50 root 2s makes that minus 17 root 2. And of course, we just keep that included in our answer. negative 17 root 2 plus 3 root 3, or 3 root 3 minus 17 root 3 if you want to change the order, it doesn't matter. And finally, on page 5, square root 8h to the 19th. This is our old friend 8 changes like that. Remember, this needs to be factored into the largest possible even exponent. Whoops, not b. H to the 18th h. So this becomes 2 root 2